Up next, we have Dr. Gregory Dutton, who will discuss support for firearms and toolmarks research and development at the National Institute of Justice. Dr. Dutton is a program manager at the National Institute of Justice, where he manages portfolios in forensic science research and development, as well as NIJ's Graduate Research Fellowship Program. Trained as an experimental physical chemist, he now works to bring advances from across the physical and life sciences into the forensic sciences. His portfolio includes imaging and patent comparison in the impression and patent evidence disciplines, advanced spectrography, and machine learning for trace evidence, and trace microbiome analysis for forensic applications. Prior to joining NIJ, Dr. Dutton was a postdoc at the National Institute of Standards and Technology. He has a Ph.D. in chemistry from the University of Minnesota and a Bachelor of Arts degree from Williams College. Thank you again for joining us, Dr. Dutton.
Hello, my name is Greg Dutton. I'm a program manager at the National Institute of Justice, or NIJ. I'm very happy to be here today to speak to you. This meeting was organized, supported by NIJ through the Forensic Technology Center of Excellence, and we're very happy to speak about the support for firearms and toolmarks R&D that NIJ has been engaged in for years, and pleased to see it sort of coming to fruition at a meeting like this. To begin with, I need to give a disclaimer. So any opinions or points of view expressed are mine only and do not necessarily reflect the official position or policies of the U.S. Department of Justice. And any names of commercial manufacturers or products are incidental only, and inclusion does not imply endorsement by me or the U.S. DOJ. So today, I'd like to talk about a few things. I'll start with an overview of NIJ's Forensic Science R&D program, which is our main way of funding research and development in forensic science. Many of the speakers that you'll hear from at this event were supported through our program, and I'll note that. Then I'll move into specifically looking at our firearms and toolmarks R&D portfolio, going through the recent history of the portfolio, highlighting some current projects that have just finished or are underway, talk about some related activities that we have going on in firearms and toolmarks. And finally, I'd like to talk about some of our recent efforts at measuring the products that R&D like this produces and the impact that they have in the real world. So NIJ is the Research, Development, and Evaluation Agency of the US DOJ. So our mission is to bring science to issues of crime and criminal justice in the US, particularly at the state and local levels. So NIJ is a science funding agency. We don't have labs of our own. We don't have any operational units of our own. So we kind of have a unique role as a science funding agency supporting criminal justice. Within NIJ, one of the science offices is the Office of Investigative and Forensic Sciences. That's the office that I sit in. And the mission of our office is to promote justice through sound science, scientists, and forensic practice. So we have a specific focus on supporting forensic science in our office. So when we talk about supporting forensic science, particularly at the state and local levels, we need to know who that is, what we need to support. The Bureau of Justice Statistics, BJS, periodically runs a census of publicly funded forensic crime laboratories. The last one with full results was from 2014. So they reported over 400 publicly funded labs in the US at all levels of government that had 3.8 million requests for service. Now you can see that the seized drugs and DNA were the biggest caseload that labs see. Only 4% was firearms and toolmarks, but they do note that 55% of the providers that responded to the census did perform firearms and toolmarks. So it's not a big part of their caseload, but many labs do perform firearms and toolmarks. And it goes without saying, firearms figure heavily into violent crime. So FBI UCR reports that firearms are used in 69% of homicides. So they figure heavily in violent crime, and also they figure in non-fatal violent victimizations. So firearms, we all know, are a big problem. So it is, while it doesn't present a big portion of the forensic lab caseload, it's an important problem, and one that NIJ has long been concerned with supporting. So NIJ has sort of three main ways that it does its work. I'm going to talk today mostly about the research and development programs. That's our kind of primary programs. The after R&D happens, the getting that that R&D out into the world is an important thing, and I'll touch on that. An event like this is a good demonstration of dissemination, tech transition, and coordination across the stakeholder community. But I'm going to focus mostly today on our R&D programs. So why is R&D important in forensic science? I like to think of sort of two broad categories that R&D is critical to support in forensic science. So the first is innovation, right? There's a constant need to push forward capabilities, to improve speed, efficiency, accuracy. And we do that by bringing in applied research from the broader sciences and bringing in those advances into forensic science. So here we're concerned with developing new tools. Forensic science also kind of uniquely continues to have an issue of having to explore the limits of its scientific foundations. So this is all about exploring issues of accuracy and reliability for forensic science disciplines that are already in use. So here we're talking about developing quantitative methods of comparison and examiner error rate studies. So we know that those are issues that have definitely come up in a lot of the blue ribbon panel reports that have been issued over the years. The 2009 NAS report, 2016 PCAST reports. So all of those reports, I think you will see, always mention that research is critical. And so NIJ's role is often to support the research that otherwise couldn't happen without the funding. Also, it's clear that research figures heavily into the factors that the courts consider in admitting scientific testimony. So I just note that the Daubert factors explicitly include reference to peer review and publication, error rates, standards, degree of acceptance. I think is another way that can be measured by publication and citation in the scientific literature. So R&D is an important part of the forensic science system. NIJ is primarily an external research funding agency. So we fund external research. We have a 6-step process of R&D. The first step is to identify the needs of the field. So unlike NSF that can just fund everything that of scientific interest, we need to make sure that the work that we fund is relevant to our mission, which is criminal justice and forensic science. So the first step is to identify the needs of the field through stakeholder engagement. And the primary way that we have done that is through our Forensic Science Technology Working Group, or TWIG. So we have in the past annually convened a group of forensic science practitioners. Over the pandemic, it has not happened as frequently, but we convene these groups and they tell us what their needs are. And we take those needs and we publish them annually so that researchers can see those needs and propose research to help meet them. So I'm just showing some of the needs from the last time that they were published. For firearms and toolmarks, it's been a while since we've had needs that have specifically talked about firearms and toolmarks. our Twig members thought that it was, since there was a lot of research activity that I'll show you, it was better not to specifically call it out, but a lot of the impression and pattern evidence needs are relevant. So I just show you some of them here. If you're interested, go and look at those. Now, in recent years, we've also pointed to research and development needs from other places. The OSAC has been publishing R&D needs for a couple of years now, and we explicitly point to those in our solicitations. They're excellent resource. So this is another list of needs that researchers can refer to try to form the proposals for the research that they'd like to get funded. Now, after we publish those needs, we put out solicitations to invite proposals from researchers. In the past, pre-2009, we had just isolated specific solicitations for certain things. So I show in 2008, we didn't allow any proposals from Firearms and Toolmarks. 2009, 2010, because of the NIS report, we specifically made a push. And so we had some specific solicitations that invited that. Since 2014, we have had two programs, one main broad umbrella program that we call Research and Development in Forensic Science for Criminal Justice Purposes, or Forensic Science R&D. And it's a broad umbrella program that invites proposals from across the forensic sciences. And we found that offering that annual invitation of proposals allows us to maintain a stable, broad applicant pool. So researchers can come to us when they have their great ideas. We have a second program more recently called Public Labs that specifically invites research done in public labs. So our main funding opportunity is posted annually, and the FY 2022 solicitation is anticipated to come out soon. It usually comes out at the beginning of the year. It's posted for several months, and our applicants submit their applications. I want to show you over time the sort of scale of the program. So our Forensic Science R&D funding program has become NIJ's largest single ongoing program. You can see that since 2009, we've funded almost 600 research projects at over $250 million. Annually, it's averaged about 48 projects or about 20 million. You can see there's quite a bit of variation because there is no single dedicated funding source for this. So it is a priority for NIJ, but there is not a single dedicated appropriation from Congress that supports this. I'm also showing here in red the applicant success rate, and you can see that as the funding has gone up and down, the success rate of applicants has followed that. So in recent years, as the funding has tightened, the success rate has gone down. We've maintained a fairly stable pool. We get about 200 applications annually, but in recent years we have funding is tight, so we have to we're not able to fund all of the quality proposals that we have received in recent years. So we funded almost 600 projects. If you're interested in looking at some of those projects, I invite you to go to nij.gov, our Forensic Science R&D page, and you can explore those projects by forensic discipline. For each one, you can click on the project, get a description of the project, and it'll also have links to publications and other products that that project has produced. So what does our Forensic Science R&D program fund? So we fund R&D across the forensic sciences. No surprise, I think forensic biology and DNA is the single largest one. But the next biggest one is impression and pattern evidence at about 20% of the total. And Firearms and Toolmarks falls under that impression and pattern evidence portfolio. So Firearms and Toolmarks is the second largest discipline under impression and pattern evidence that we fund. So of course here at this meeting, I don't need to go into this much. You're going to hear a lot about this, but for Firearms and Toolmarks, we're talking about those toolmarks that are created on evidence, bullets, cartridge cases that result from the tool marks on firearm surfaces. Shout out to these images taken from the NDAA publication by Robert Thompson. So to look now specifically at the Firearms and Toolmarks funding that we've funded under Forensic Science R&D, I've identified 48 projects since 2006. We've had an annual average of about 3 projects for $1 million. You can see there was definitely a spike in 2009, after the NAS report, and we have really tried to maintain stable support for the portfolio because it is an important one. But of course, it's, with limited funding, we have to make sure that we support all of our disciplines. But we have definitely made a concerted effort to continue supporting Firearms and Toolmarks R&D over the years, you can see. Now, looking at those 48 projects, we've got quite a number, very diverse set of projects. Looking at them, I kind of group them into about 6 sort of groupings of the areas of research that they tend to cover. And I'll note that this has changed a bit over time. So we've got projects in this list going back to 2003, 1997 even. And early on, you can see that they focused on instrument development and quantitative measures of similarity, right? So those were the early days of applying 3D imaging instruments to forensic firearms and tool marks, and trying to develop ways to quantitatively compare those images, right? Over time, we've seen more and more projects come in that have focused on things like virtual comparison microscopy, error rates, weight of the evidence. So taking the next step to applying statistical comparison to evidence. And then of course, standards. So we'll see when we look at the current projects, kind of how the emphasis of these different concerns of Firearms and Toolmarks R&D have kind of changed. Now, among all those projects, there have been a few continuing lines of research that I want to note because they've been so significant. They figured so significantly in our Firearms and Toolmarks portfolio, and I think they've had a great effect on research in the field in general. The first one was to intelligent automation. It started back in 1997, I believe. When we go that far back, NIJ's grant records are not so great. So it was a bit of a hunt for me to track down some information. That line of research continued for a number of years. That was really one of the first efforts to apply 3D imaging to firearms and tool marks. Oh, intelligent automation was PI Ben Bachrach. We had a line of research at Ames Lab that looked at tool mark measures of similarity, synthetic tool marks, and I think that was very important to the field too. NIST, NIJ and NIST have had a relationship going back many, many years, and I'm sure it predates, even 2003, where I note the beginning of this line of research. But NIJ has supported NIST firearms and tool marks research for years and continue to. In the early 2000s, it was through the Office of Law Enforcement Standards at NIST that NIJ supported a lot of projects. More recently, NIST researchers have applied to our R&D solicitations and been awarded competitively. So we continue to support them through competitively funded research. We'll look at some specifics of some of the NIST projects that we've supported in a second. Cadre Research has had an ongoing line of research, a number of grants since, I believe, 2012, and that has been another important one in the field. So let's take a look at some of those recent ones. So Cadre has had a sustained line of research, discrete research projects that really started with instrument development So they applied a novel imaging technique to firearms and tool marks, developed an instrument, took it through validation and production. And along that line, they really kind of led the way in validating virtual comparison microscopy in laboratories, because they were one of the first that really had, you know, instruments in the labs for examiners to use. They have a publication of one of the first, I believe the first virtual comparison microscopy error rate study. I'm sure we'll hear from Ryan Lilly and the PI later in the meeting, I'm sure. NIST, one of the recent projects that we have funded at NIST in Firearms and Toolmarks was the NIST Ballistics Toolmark Research Database, or NBTRD. This is a database of 3D firearms toolmarks images for researchers to use to kind of test and improve their matching algorithms. So this was supported by a couple of awards to NIST. NIST, more recently, so the PI here is Alan Zhang. More recently, they've been working with FBI Lab to create a new database, a separate database of reference populations to use to try to make the sort of statistical basis of comparison of firearms toolmarks comparisons. Another project at NIST that just ended recently was to develop surface metrological standards for firearms and toolmarks imaging. So here the idea is to develop physical reference standards for 3D imaging. So these are reference standards. They're sort of, you can see they're kind of created at the end of a stub that is the same dimension as a cartridge case. So it can be put into a 3D imaging instrument, and it would have a number of surface metrology standards for measuring things like step height, roughness, flatness. And so the idea there is to make a number of, say, resolution, flatness, step targets so that a lab can run this standard on their machine to make sure that the images that they're getting are calibrated to acceptable standards. So that if if you're measuring an image on one instrument, you're going to get the same image on another instrument, no matter what kind or what manufacturer, to an acceptable degree of tolerance. So this is very important for really bringing this technology into the lab in a standard way. And I should note that this is moving toward development of a NIST standard reference material. So look for that soon, and you probably will also hear a presentation from them at this meeting. I want to look at now the active projects that are in the Firearms and Toolmarks portfolio. So we have about 9 projects in Firearms and Toolmarks that are active. The ones that are scheduled to end sooner are toward the top. We have a number. I've color-coded them by the sort of, again, those sort of areas of interest that I noted. So we have a number looking at error rates. The top one is a co-funded project with National Science Foundation and CSAFE. Virtual comparison microscopy projects. We have a number looking at, again, quantifying measures of similarity, and some statistics projects that are really hashing out how to take those comparisons and translate them into statistically significant statements of the weight of the evidence. So again, here you don't see so many instrument development projects here, because I think generally the field is moving toward implementation of these methods in consistent ways across instruments, labs, and so that's kind of, this is the mix that we have right now. So look for these projects to be producing publications and other products soon. One of the main ways that we get the information of what our R&D produces out to the field is through our Forensic Technology Center of Excellence, or FTCOE. that organized this meeting. So they do that and so much more. I really like their statement of what they do here. The FTCOE provides scientific and technical support to NIJ's R&D efforts by facilitating transfer and adoption of technology into the criminal justice system. So this is an important part, the next step to take that research and put it into the field. And they do many things to do that, webinars, meetings like this. They've been organizing and facilitating the TWIG 3D2T working group, which is working to get these 3D forensic firearms and toolmarks imaging out into state and local labs. So this is another important part of our R&D program is the FTCOE. So I want to talk a little bit about how we, recent steps that we've been taking to try to do a more thorough job of measuring the products of our R&D program and the impact that they have. So just to list here of, a few of the things that R&D can produce. Peer-reviewed publications is first and foremost. That's the foundation of science, is peer-reviewed literature. So, we're going to be very interested in tracking that. Presentations, patents, and grant reports that used to be the sort of primary product of our research projects. We strive to make sure that all of these are captured in NCJRS, the National Criminal Justice Reference Service, so that the public, everyone can find them. And we're also interested in trying to measure the impact of these products in the real world. So we can look at those in a number of ways: citations in scientific literature and in court documents to see if those publications are being referenced. Technology that is ending up in the field, workforce and students that are supported under our project. So there's some of the ways that we are interested in measuring and tracking the impact of our programs. One of the most important things that happened in the past number of years for our NIJ's R&D programs in general was a change in 2015 where the NIJ director decided to renew the focus on publication, and the final grant deliverable was changed to a shorter format so that our researchers could focus on writing and publishing in the peer-reviewed literature. So there's an enhanced expectation to generate scholarly products, because it's really those peer-reviewed pieces that form the basis for science moving forward. So we can apply bibliometric techniques to look at the publications that our researchers produce and the citations that they produce. So we use Web of Science. You can use other things. This is for the Forensic Science R&D program in general. You can see nice linear growth in publications over time and neatly exponential growth in citations. We can do this now for the Firearms and Toolmarks portfolio specifically. And you can see it's a lot noisier because we don't have as many. But we do see a kind of stable production of publications for this portfolio, averaging around 3 per year, and nice growth in citations. So we look at those, we can sort of zoom in on the top cited ones. The top one is a kind of human factors one that's related to Firearms and Toolmarks. And the first one that's kind of purely Toolmarks is Gambino and Petracco paper. So we can look at what's being cited. Journals, we can see that Journal of Forensic Sciences is the most common place for our Firearms and Toolmarks research to come out. I'm going to skip over some of this stuff so we can take these measures and we can look at the portfolio and compare projects to see what's productive, what's not, and we can take that into consideration when we think about, do we continue a line of research? Do we fund a new applicant? So we can look at those things and consider them. We can pull all that information together for the whole portfolio. I'm going to zoom through these for both publications and workforce. I'm going to get to this, and we can see kind of the median Firearms and Toolmarks project lasts for about 2 years, results in about 1 publication, which is lower than some of our other portfolios like trace evidence, analytical chemistry, tend to produce more, to publish more, but those are just practices for that field. Cited about 14 times, make 5 presentations, 0 patents on average, and support 3 researchers and 1 student. So we see what a kind of an average project is, so that we have a benchmark for judging our other projects against. One of the challenges here is really trying to find good ways to measure real world impact, like technology adoption or court citations. So we're trying to improve the ways that we do that. And also we're very interested in facilitating the sharing of information like open access publishing, which we know our researchers do not publish open access as much as we would like. We want to be able to have those publications available to everyone. So we're looking at ways to improve that. And it's always a challenge to sustain productive lines of research, considering our limits on available funding. So those are, it's kind of an update on NIJ's Firearms and Toolmark Research and Development. Very happy to have the chance to talk to you today, and I look forward to a productive meeting. Thank you.
Excellent. Thank you, Dr. Dutton, for your presentation. We no longer have time for a question and answer session with Dr. Dutton, but please type any questions you have into the chat pod and we will get those answered for you.